Let me close this one here. Okay, do you see my screen, guys? Yep. Okay, so last class, guys, we finished the very quick review of statistics and the way we're going to use it. Okay, what is left at this point is, well, let's do a couple of examples. I think we did a very quick example. Now, let's do another example just to warm up. Okay, assume, guys, that X bar equals, let's say, 91. Let's assume that S equals, let's say, 3. Okay, let's assume that your sample size equals 100. Okay, so let's assume that you have a confidence level of 90%. And what I want you to tell me is what is the confidence interval for mu. Okay. So this is a more general case, guys, in which you don't know sigma, you know S. Okay, remember that S is my sample standard deviation. Okay, so three minutes to solve. We'll bring some water.
Hey, Professor.
Yes.
I think Kutso is trying to get in right now.
Oh, yeah. Thank you. Yeah, they're joining now. Thank you. Okay, guys. So let's continue. So tell me, guys, as soon as we are using the sample standard deviation, this means that we need to use the t distribution, correct? Okay. And my formula then is going to be mu belongs to my x bar plus minus my t. N minus 1 is the degrees of freedom that multiplies s over the square root of n. You agree with me, guys? Yep, perfect. So x bar, I know x bar, sorry, I know what is x bar. X bar is equal to 91 plus minus, okay, I know s, 3 square root of 100, that is 10. And the only value that I need to find here is the t with n minus 1 degrees of freedom. Agree? And for that, I need to know that I have a 90% confidence level. So basically, the t, remember, it has fatal tails and normal in general. And what I want from here equals 0.05. This is alpha over 2. And this part here is alpha over 2, also 0.05. Agree? So this is my 95% confidence interval. I need to find this t that is minus of this one here. So how do we do that? Do you remember? Do you remember how do we do this in Excel? Guys, we have done that, right?
No, I don't think we did t distribution.
Oh, we haven't done t distribution.
Or maybe I'm wrong.
Guys, we haven't done t distribution. Guys, someone?
No.
Oh, okay. So this explains why. Okay, so let me go back again into here. Then let me explain this part here. Okay, guys. So when this is a generic case, when we don't know the standard deviation, so basically if we have data, I can simply compute the standard deviation using Excel, correct? Okay, this is what is called the sample standard deviation. When I have the sample standard deviation, guys, I need to use, instead of the normal distribution, I need to use one distribution that is called the t distribution. Now, we'll do some notes here. The t distribution. Guys, the t distribution looks like this one. Okay, it is symmetric like the normal distribution, but it has fatter tails. Okay, wider tails here. If you compare this with a normal distribution, the normal distribution should be something like, hopefully I can draw this correctly, something like that. So the blue is normal, and the red is the t distribution. Okay, so it has fatter tails. Tails are the extremes, here and here. Now, what is interesting about the t distribution, guys, always you want to find something like that. T n minus 1. So what is this n minus 1? Is what is called degrees of freedom. And what is interesting from here, guys, is that you need to remember the following rule. If n is small, it's large. Let's go with large, meaning that n goes to infinite, so very large n. The t distribution is similar to normal distribution. Okay. So this is the rule. If n is large, the t-distribution looks like normal. However, guys, as is most of the case, if n is small, the t-distribution has fatter tails. Okay, so the probabilities of occurrence in the tails is larger than the normal distribution. And this is exactly what we're going to be using here, guys. So if you see the sample, we simply going to use the t-distribution. My formula instead of the z, remember before we had the z here, that represent the normal distribution, the standard normal distribution. We're going to have a t n minus 1 degrees of freedom. Okay, copy this and I will show you how to do this in Excel very quickly. Ready? Okay, so let me show you my Excel. How to find the t, okay? So in Excel, let's put the 0.05. That is one of the tails of the t-distribution. And then we do equals t dist, this one here. And then we simply enter sorry, let me see. Give me 1 second, I always confuse this with Excel. Yes, it is T inverse, guys. T inv. The probability is 0.05. And the degrees of freedom, in our case, what are the degrees of freedom, guys? It's always n minus 1 in our cases. So it's going to be equal to what?
99.
99, exactly. And then here we go. Minus 1.66. Okay? So minus 1.66 to the left, 1.66 to the right. Let me put this bigger, just to be sure that you get it. It's T inverse. A1 is a 0.05. 99 is the degrees of freedom. Okay, remember we have 100 observations, minus 1 is 99. Okay, so in that case, is as before. So this is going to be 1.66. What was that? The your number 66? 0.39. So it's 66. Agree, guys? And then you solve it, and you please give me the results. Mu belongs to what and what? Someone? Between what and what?
90.5 and 91.5.
Someone to confirm?
Yep.
Yep, confirm. So basically a 90% significance level, sorry, yes, confidence level. My population mean is going to be between 90.5 and 91.5. Got it? Okay, one last thing to go back to finance, to global financial markets. Questions? Do you have questions? So now let's put this into perspective. Let's do one more case. So guys, if you go to question 4D in the exercises that I gave you, they provide you the following information. Remember that when we are here and we're talking about a price in 1 month, for example, price or exchange rate in 1 year, these are expectations. Do you agree? So expectations means that you are not 100% sure about a single result. Right? So normally what you have is based on the statistics, based on the past history, what you try to come up is with a table that creates a probability distribution, right? And that's what we have in exercise 4D. So let's do exercise already 4D. Then we have here, we say that, the expected value, the expected exchange rate at time 1 can be 3.01, 3.05, with a probability of 50%. The expected value at time 1, okay, I will say this assumption 1, can be also 2.90 with probability 30%. Or in the future, the expected value 1, assumption 3, or probability 3, or value 3, random value 3 equals 20%. Do you understand this data? So this simply means that you are 50%, you have a 50% probability that the exchange rate in period 1 is going to be 305. You have a 30% that the exchange rate is going to be 2.9, and then you have a 20% probability that the exchange rate is going to be a 3. Okay, so exchange rate here is defined as soles, this is a Peruvian money, divided by US dollars. Okay, so this is the definition of the exchange rate in this case. Now, guys, how do we create something here? This is a, do you agree with me, guys, that this is a probability distribution? Right? A probability distribution simply means random variable, in this case, my exchange rates, multiply or attach to its probabilities. Now, from here, guys, when we have a probability distribution that is a discrete like this, we need to find, first of all, what is my expected exchange rate? Remember, the expected exchange rate, guys, as usual, as we did before, is simply going to be exchange I, probability of EI. So in this case, I goes from 1 to 3. So this means simply, and then I will need your help, this is going to be 3 of 5 times 0.5 plus 2.9 times 0.3 plus 3 times 0.2. Can you help me with this? Okay, so this is going to be my expected value.
2.995.
2.995. So this is my expected value. Okay, you can see, guys, this is a weighted average. Okay, what are the weights, the probabilities? Now, we don't need only the expected value, but we also need the variance. Okay, I will call it S squared. Or let me call it better variance. Variance of expected change, the exchange rate. So the formula for this one here, guys, is the same as the one that we use. From I equal 1 to 3. You see? So what is E bar? This one here is E bar. So if we use the formula, the variance of E is going to be basically, what is that? 305 minus 2.995 squared multiplied by 0.5 plus 2.9 minus 2.995 squared multiplied by 0.3 plus 3 minus 2.995 power 2 multiplied by 0.2. I need your help, guys, giving me this number. So the standard deviation of E, that is simply the positive of the square root of equals. Okay, so someone, what is the variance? Someone?
I got.
I get
Oh, go for it.
I get 0.0042.
0.0042.
Yeah.
Yep. Okay, the standard deviation, sorry, the square root of this one here. Yeah, I have, yeah, this is correct. I will just add the 2.5 just to have
I
it.
got a 0.065.
I got the same number, 0.00425. I got this number. Can you verify, please?
Yep.
Yeah. No, I mean
Yeah.
like when you square root of 0.
Oh, yeah,
0.065.
yes, completely right. This is my standard deviation. So guys, this one here is my point estimate. Of, let's call population mean of exchange rate. Do you agree? Okay, so remember the point estimate, the confidence level of a point estimate is equal to what? Guys, the confidence level for a point estimate is equal to what?
0.
0. So we don't want that. So what we need to create is a confidence interval. Okay, let's assume, let me assume here, %90 confidence level. Okay, so in these cases, guys, what we normally use is a normal distribution. So what we are going to say is based on this, the population mean, so I mean the mean of the exchange rates, is going to belong to the interval of E bar. So this is belongs, sorry, let's be clear. This is belongs to plus minus Z and my S, okay? Remember that S normally goes with T, but I don't have a N in this case. I don't have a number of observations. We don't know the number of observations here. So that's why the formula modifies like that. And also, if I don't have N, I cannot use the T distribution, do you agree? Because the T distribution depends on the degrees of freedom depends on N. So my formula now is going to be much simpler, and it's going to be like that. So we do this. This is going to belong to 2.995 plus minus, this is going to be a C of 0.9, it's going to be 1.64. We did this last class, guys. That multiplies my S. So finally, guys, my mu is going to belong to what and what? Can you please give me these numbers?
Sorry, Professor, where did we get 90%?
No, I give you this number. This normally comes from you. Yes.
Exercise set?
No, this is data. So you assume, you know what, I want to do a 95%, I want to do a 90%, I want to do a 99%. It's up to the researcher. The number that we normally use is 95%.
Mm-hmm.
Okay, I want to be 95% confident, but I just, for example, I said, okay, I want to be 90% confident.
All right. But in the example, in the exercise set one, it's
Always.
95%.
You need to have, the default is 95%. Oh, the exercise is 95%?
Yeah. It says, assuming the FX rates are normally distributed and for a confidence level of 95%, what is the confidence interval for this?
Yeah, 95%.
All right.
You're right.
Okay.
Yeah, let me. So it's going to be a 95%, guys. This is not 1.64, it's 1.96. If you can help me with that, with this, please.
I got 2.8676 to 3.1224. 1224.
Yep, someone to confirm.
Confirmed.
Yeah, perfect. So now, guys, you have your confidence level. So confidence interval. Okay. So now let's learn how to use this stuff. Okay. And I will do a simple example for you, and then you solve it. Everyone is with me here?
Sorry, Professor. What distribution are we using here? T.
Normal. No. We cannot use T because T, remember, requires N, number of observations. We don't have number of observations here. Do you see that?
Yeah.
Okay, so that's why we approximate this as a normal distribution.
Okay.
Okay, that's C. Okay, so now let's go and let's take a look to the following example that we did before. So let me copy my, I know that this one here belongs to 2.876 and 3.1224. Okay, so let's keep this in mind. So now let's go to the following example, guys, and you tell me. Okay, so I have my 10 million euros, a loan on 10 million euros. Okay. And this one here is going to be for 2 years, the typical example. My exchange rate here, so I'm here, and my exchange rate at time 1 is actually equal to 2.87. Okay. So if I assume that my exchange rate at period 2 is going to be equal to my point estimate of 2.995. So this is the number that we have found just a couple of minutes ago, remember? So this is my point estimate. Okay, my interest in euros are going to be equal to 5%. My interest in dollars equals 8%. And my question, as usual, guys, is that you are here, okay? And you have the option to change your debt in euros for a debt in dollars. Do you do it, yes or not, based on this assumption? Okay, 5 minutes to do that. It's very similar to one example that we have done, but this is very common for swaps, money swaps. Okay, guys, ready? You do it or not? This type of examples, guys, should be very easy. It's something real life happens every single minute. Do I exchange? Do I do exchange? I use the exchange rate advantage, the exchange rate in my advantage, yes or not, etc. What is your conclusion, guys? One more minute and then we solve it. Ready? You change, you exchange, you swap the debt or not?
You don't?
You don't. Okay, so let's do this together, guys. I know that these $10 million at period 1 are going to be worth 10 times 1.05, correct? So this implies this is equal to $10.5 million euros. Agree with me? Then if I continue moving, if I keep my debt in euros, and I want to know what is the value in euros, so this is euros, I simply multiply again this by 105, and then I obtain, what do I obtain here? Someone? What is my debt in euros?
11025.
11.025.
000.
Yeah, that's okay. Agree? Perfect. So these are euros. Now, in order to exchange, what I need to exchange is this 10.5. So if exchange, if swap. I need to compute first what is this 10.5. So this 10.5 in dollars is going to be 10.5 times 2.97. So this is equal to how many dollars? $31.185.
Yes.
Perfect. Now, if I have this one here, what is the value of this in the future? Is going to be times 1.008. This one, because I'm in USA. So if we do this, what is the value here?
3367. 98.
98. Okay. Now we need to compare. Okay, so let's do the comparisons here. Now I will transform everything into dollars. So 11.025, if we agree with this one here, if we arrive to period 2 and then we observe this exchange rate, so this should be equal to this. Times 2.995, so this is equal to what? Someone?
I got a 33,019,875.
Yeah, 0.2, let's round it,
All right.
right? Excellent. So if I compare this with this option here, that it is 33.6798. Which one costs more? So this is dollars, this is dollars. Which one costs more money?
The bottom one, if you
The
swap
bottom
it.
one. So basically, as soon as this number here is larger than 3302, where's your conclusion?
Do not swap.
Yeah, just keep it in Europe. Do you agree? Now, guys, this is based on my point estimate. What is a probability? What is a confidence level for a point estimate? 0, right? 0. However, I know that this one here belongs to this result here, has a confidence level of 95%. Got it? So what I will do is a sensitivity analysis. And what is sensitivity analysis? The only thing that is going to change, guys, is that for period 2, I will start changing my assumption. What happens now if my period 2 is equal to the lower bound, 2.876? Okay, so this is my new exchange rate. So if my exchange rate is 2.876, my euro debt debt from Europe becomes 11.25 times 2.876, and this equals what?
30. Hold on, joke. 31.707.
Yeah, someone to confirm?
Confirm.
Confirm, perfectly. And now what we do is we compare. Now, if the exchange rate, guys, is this number, that is the lower bound here, what do? This number here is smaller than 33.67. Do you agree? So what is your conclusion?
Do not swap.
Everyone agrees with that? Okay, so one additional thing that I can do from here is if I decide to do the swap, okay? So this implies, guys, that I will be basically losing 1.98. You agree? Agree with me, guys? 1.98. Guys, you agree?
Yeah.
Okay, so that's why we say no swap. Now, this is case one, lower bound. And now we do upper bound. So what is the idea of upper bound? The value is going to be what happens now if the exchange rate at period 2 equals 3.1224. Now, with this number, what is my debt from euros transformed into dollars? Well, it's going to be 11.025. That is in euros. So this is euros. That multiplies 3.1224. So what do you get here?
Uh, 34.424.
So in this case, guys, as you can see, this number here is larger than your 33.6798. So what is your conclusion?
Swap.
Swap.
Perfect. Now, what is my expected gain in this case? So my expected gain is going to be 34.424 minus 33.6798, correct? So my expected gain is going to be equal to 0.46. So in this case, this is my gain. Loss and gain. Agree? So here, guys, from these upper and lower bounds of exchange rates, I can build my confidence interval for gains and losses expected. We can say at 95% confidence level, my gains and losses are going to be located between minus 1.98 and 0.46. This is the final conclusion. You see that? So now it's not only a number that you say, oh, no swap. Now we have an interval. So you know what? According to my statistics, if the numbers become, if the exchange rate is between 2.87, 8.76, and 3.1224, my losses are going to be minus 1.98. My gains and losses are going to be between minus $1.98 million and $0.46 million if I do the swap. This is if to swap. Make sense to you guys?
Yeah.
Everyone is following me? Because remember, guys, the decision is not made here at 2. The decision is made at period 1. So you really need to use the statistics to decide. So can be, you know what, with a 95% confidence, the values, the exchange rates are going to be between these intervals, between these limits. Got it? So what is your worst case scenario? My worst case scenario is if the exchange rate is 2.876. If I do the swap, I would have lost minus $1.98 million. But if I'm lucky and the exchange rate goes at 3.1224, my profitability is going to be 0.46. My gains are going to be from this transaction going to be 0.46. Make sense to everyone? Guys, questions?
So the point where they break even would just be that.
Oh, we
third-
can do. Yeah, no, you're completely right. There is something missing here. So what is my break even? Remember, to compute the break even, what I need to do is 11.025 times E break even, I will call it, needs to be equal to 33.6798. Do you agree, guys? Guys, do you remember this? So what I want, break even implies that I'm indifferent between swapping and keeping the debt in euros. So basically, what is the exchange rate that makes this number here, multiply this number here by this number here, gives me this number here. So from here, guys, my exchange rate, break even, is going to be equal to what? Can you please provide me this number?
3.0549.
0.549. Do you agree? And what is interesting, guys, is that, and check this one here. This one falls in between a confidence interval for mu, for expected return, that is simply 2.876, 3.1224. You see? So in this case, guys, you can be more confident about these results, because your break even is in between. You can argue, yeah, well, my break even is here, so perhaps I will get this number or above this number. Because the break even tells you guys, if the exchange rate at period 2 is larger than 3.0549, swap. If this number here is smaller than 3.0549, basically do not swap. Okay, guys? Everyone is with me? Okay, guys, questions?
Professor, I have a question.
Yeah, go ahead.
So we said that the confidence interval for gains or losses is from negative 1.98 to 0.46. But how do we know that the confidence level is 95%?
Oh, because we are based on this one here. So remember,
okay.
we know that the confidence level 95% provides me these ones for exchange rates. Do you agree?
Mm-hmm.
Okay, and everything is developed on the 95% confidence level. So if we use this number here and this number here, we are preserving that confidence level. So that's what I've done here. I use this one here, this, and this one here, this. You see? So I'm preserving the confidence level. Got it? So it's simply translating the, instead of exchange rates, I'm gonna use gains and losses. Okay, and that's
Understood.
it. Perfect. Okay, guys, questions. So I was mentioning before, guys, I think not everyone was in the class at the very beginning. The exam is not going to be next class, it's going to be next class. So I think it was April 6th. Okay, so April 6th is going to be the first midterm, guys. And it's going to cover up to here, all what we have done up to here. So what is going to be next class, what we're going to do next class is you are going to discuss the assignment that I provide you. Question 1, 2, 3, and 4, everything. So I will call you, okay, Paul, what do you think about question number 1, for example? Okay, and Kagiso, can you complement question number 1? So let's start building up. We're going to start building up our answers. Okay, so everything that we have covered in class, guys, is I think kind of condensed on the on this exercise. Make sense to everyone? So for today, we're going to stop here. I prefer you, if you can invest some time already on reading and trying to solve this exercise set. And next class, next class, we're going to solve it. We're going to discuss about that. So just as a matter of review for the exam. So it is going to be more useful, guys, if you really study, like as if this is the exam. Got it? It's going to be more useful. Otherwise, we're going to simply start talking about things that you're not going to understand or you're not going to remember. Better if you study. And then the exam is going to be on a couple of weeks. Okay? Questions, guys? No questions? Okay, excellent. So for now, we stop here and then we'll see you in a week. Please be ready. If you have questions, email me. I will be answering you because now we are very close to the midterm. And I want you to succeed on this midterm. Okay, guys? Perfect. So see you in a week, guys. Take care and good night. Our friends from South Africa, it's too late for you. See you, guys. Take care.
Thank you,
Thank you,
Professor.
Professor.
Thank you.
Bye, guys.
Have a good one.
Same to you. Bye.